Today's video, I'm just going to go through some examples of polynomial long division and also just recapping some of the key ideas that the factor theorem tells us. So, reading the first question, it says given f3 is equal to 0, and then I've been told to factorise this cubic of x cubed plus 2x squared minus 17x plus 6. So, let's just dissect what this means. If f of 3 is equal to 0, that means 3 is a root of the equation. So, if f of 3 equals 0, straight away, what I can deduce from that is that x take away 3 is going to be a factor. So before I do anything else, I know that I've got this x take away 3 term, which is a factor, and if I've got x cubed plus 2x squared minus 17x plus 6, I know that what I'm looking for next is a quadratic, and that's going to give me some f of x. So this is a question, how do I find what this quadratic term is? In today's lesson, we looked at the factor theorem, and we also looked at long division. So what does this state? This states that if I have x take away 3, and I do a long division, almost like the bus stop method, for x cubed plus 2x squared minus 17x plus 6, and all I'm doing is I'm thinking about, well, what divisor of x here and x cubed? Well, that's going to give me x squared. So I've got this x squared as my first term. And I just want to multiply through x squared by x minus 3. When I expand that out, that's going to give me x cubed minus 3x squared. So that's my first step. Now it's just a subtraction to work out what my next thing would be. And I'm expecting a quadratic because these x cubed terms have cancelled each other out. So this is going to give me, well, 5x squared minus 17x plus 6. Great. Now I'm on the next row. I want to know, well, x and 5x squared. Well, what do I need to multiply x by to get to 5x squared? And hopefully we should all be screaming, this is plus 5x. So, doing this again, plus 5x multiplied through by x minus 3. It's going to give me 5x squared again, which is what I'm expecting. Take away 15x. And I do the exact same thing. That's what I've worked out, so I'm just going to take that away, which leaves me with, well, it's going to be 0. Oops, sorry, I'll put a 0 up there. 0, and this is going to be take away 2x plus 6. So my final step, what am I going to multiply to give me negative 2x? Well, if I have an x, it's going to make sense that it's negative 2. So take away 2, and that's going to give me, let's just check that this works. 2x, negative 2 times negative 3 is positive 6. So doing the subtraction again, that's going to give me 0 plus 0. Lovely. We knew it was a factor, so what does that mean I'm expecting? Well, I'm expecting these zeros because I'm not going to have any remainder. And what does it factorise nicely? It gives me x squared plus 5x minus 2, which is going to go next to my linear factor. If it said fully factorised, I would then look at x squared plus 5x minus 2, and I'd think about how can I reduce this further? Does this factorise into another 2 linear factors? Or if it was a cubic, can I then do a factorisation? But for now, that's not the case, so I'm happy with that. There is another way you can do this, and as we start to get better at mathematics, we can hopefully get to a stage where we just look at it and we know what the answer is going to be. But another way we can do this is by looking at just simply the grid method. So it's important we know how to do long division, but if I just show you quickly the grid method, what I would do is I would first of all imagine this as if I was expanding a linear term and a quadratic term to give me this cubic term. So if I had a quadratic term, I don't know what that is yet, but I know it would be of the form of 3 things together, and I'd have that linear term. So how does this work out? Well, what my f of x is my f of x has got 2 terms which can only ever be made in 2 spots of my multiplication grid. X multiplied by something is going to give me x cubed. So I know that this here has to give me my x cubed term. And the only way I can get a constant is if the 2 constants multiply together. So straight away I can work out what my x squared term is in my quadratic and my constant term. X multiplied by something is going to give me x squared. And this has to be negative 2 and I'm just confirming earlier on I've done the same thing. But now I've got more information I can put in my grid. This is going to give me negative 3x squared. This is going to give me negative 2x. And the process is the exact same. If I've got negative 3x squared, but what I need is positive 2x squared, my other value must be plus 5x squared. And if I've got negative 2x and I need negative 17x, my other value must be negative 15x. So that they sum to give me my cubic. And then you just know that this is going to be plus 5x, and you get the exact same answer. So we need to know how to do long division because it's really important. But if you want to just check, then there's a grid method that you can use. Okay, next question, looking at this right hand side now, so I'm just going to zoom in a little bit so we're not distracted. Given that f of 4 is not a factor, find the remainder using polynomial division for f of x. Well, if f of 4 isn't a factor, I know that it's not going to equal 0, so it's not going to help me. The only thing that f of 4 tells me is that what I'm going to be dividing by is x take away 4. So this is going to be my divisor. So I just set it up like long division, like a bus stop. So it's x take away 4. And again, I'm just going to set it up as 2x cubed minus 5x squared minus 16x plus 10. This is where I'd encourage you to do long division because the grid method may get a little bit messy when you're trying to find a remainder. So, what's my first term got to be? Well, it needs to make 2x cubed, and I'm going to be multiplying by an x, so it must be 2x squared. Great, let's times through. 2x squared times x is 2x cubed, which is the reason I did it, and then it's going to be take away 8x squared. Let's work it out for subtraction. We're going to get a 0. Good, and then negative 5x squared, take away negative 8x squared is plus 3x squared. And then take away 16x plus 10. Do the same thing again. How do I get to 3x squared? Well, I've got an x, so it must be plus 3x. Times through, I end up with plus 3x squared. And then this time it's going to be take away 12x. And so when I do my subtraction again, I don't like the fact that that's a different colour, sorry. So when I do my subtraction, that's going to give me 0 plus 12x is going to give me plus 4x plus 10. Sorry, negative 4x even. Sorry, away with the fairies. Negative 4x plus 10. So what am I going to have now? Well, I'm going to have a negative 4. Negative 4 times x is negative 4x, which is the reason I had it. But then it's going to give me plus 16. So looking at my final line, I'm going to get a 0 here. However, positive 10, take away 16, is going to give me negative 6. So what we should notice, hopefully, is that this indeed is a remainder, and I would say that the remainder is negative 6. And we could also deduce from this that f of 4 is going to be equal to negative 6 by looking at the remainder theorem. So what I would like you to do from here, hopefully these sort of two examples have sort of given us another way of having a go at these. I'd like us to have a go at these questions here, especially before sort of the end of the week, and make sure you're confident you can do these. In the next few lessons, we're going to be focusing on problem solving. So I will see you in those lessons, and thank you.